Hello, welcome back to our UTOK book series, our new series going chapter by chapter on the new UTOK book. Today we start on the periodic table of behaviors. Last time we did mindedness, right? And all of these current episodes are on the descriptive metaphysics of UTOK. And the PTB is an important part of it. It's less known the tree of knowledge system, but it's like the cousin to the tree of knowledge, right? It's also very important, and it's also seen as an extension of the TOK system. So I'm excited to talk about that.
Lovely. Yeah. So just to situate ourselves where we are, obviously UTOK finds itself located in addressing the problem of psychology. First, there's the meta-theoretical thing. We'll start getting into that after this. But then even beyond that is this descriptive metaphysics, which basically means what is actually science? Science in general, modern empirical natural science, what's it doing in the world? Where does it come from? How do we think about it? How do we think about mind, and how do we think about behavior? That's the argument that the problem of psychology is that we don't have a system for describing these concepts in their proper relation. And so that's crucial to UTOK, is the ability to tell us what these things are. We talked about mindedness, which is this third dimension of complexification. We're going to talk about map of mind next time, but here we are creating an extension of behavior with a periodic table of behavior that really gives us a much richer conception of behavior. It's alluded to in the tree of knowledge. Its cousin, the PTB, extends it significantly.
Cute. And just to give a face to the name, here's the periodic table of behavior. People haven't seen it yet.
I
It
took it
looks
down from our
complicated.
monastery, dear.
Yes, we have different versions of it because we're so rich artistically, right? So, like you said, it's all about behavior, right? It includes mind. If you look at it closely, you're going to see the planes of existence from the TOK. That's why it's cousin to it, right? There's matter, life,
Totally.
mind, and culture. So it's a table of behavior that includes mind, and we're going to talk about that. First, I think it's important to define behavior, right? If it's a table of behaviors, you're all familiar with the periodic table of the elements, but this is broader. So how is it broader, and what's this behavior that we're talking about here?
Lovely. So you're right. The periodic table of the elements is actually inside of this. What do we mean by behavior? The argument that I lay out in a new synthesis is that behavior is actually the central concept in science. And really, if you look at a definition, many definitions, science is about describing the structures and behavior patterns in nature, or at least natural sciences. And this is the periodic table of behaviors in nature. And what do we mean by that? Well, we mean that it divides the world in terms of its basic categories into entities. These are things we pull out as having the figure in a ground, that's the field, and then they change over time. So the fundamental sort of core metaphysical epistemological argument is that there is the concepts and categories of an entity, a field, and a change. And so that's basically what is behavior. It's change in entity field relation over time. Okay. And then what's the element of behavior? These three components. And then the argument is that's a descriptive metaphysical claim about an entity relative to a field, which actually gets really complicated in things like quantum theory, like where's the field, where's the particle, all of that fascinating as you really get increasingly general. It's like it's quantum field theory says sort of the particles disappear, they're vibrations in fields, but that gets at the bottom of it. And then we have the argument from UTOK is that we can split this concept of behavior after the descriptive metaphysics of entity field change into epistemological lensing for science, which is that science observes and describes behavior from a third person or measurement to observer relation, whereby anything can get measured by a professional can then be observed by any class of intersubjective professionals. So we can then watch object field change. That's the epistemological, methodological commitment of science. And then the other thing that we have is that the argument is that nature itself can be described as patterns of entities within which they have structure, and then they move across fields. And then then that gets us to the tree of knowledge, which is this big picture view of that topological unfolding, and the periodic table of behaviors in nature. That's the full name, but periodic table of behavior tells us what the entity field relations are with greater specificity. And so I'll stop there, but that's the bridge from behavior into science into the PTB.
Lovely. No, I love that definition of behavior. I always thought it was really cool. So just to sort of categorize it, there's a metaphysical claim, right, that behaviors in nature, that the phenomena in nature are behaviors, right?
Well,
Although it's
that's
scattered culture, or
yeah. I
that's
would
the
just
ontological argument
That's the ontological claim. The metaphysics is that we need the concepts and categories. We need our entities, fields, and change.
to be able to
That's our
understand the
right.
ontology and the
Exactly.
epistemology of science. So there's those three claims, the metaphysics,
Totally.
the ontology, and the epistemology that we
Right.
tie to behavior. That's really helpful. And one way that you talk about the TOK a lot is that it's this map of complexification of natural behaviors,
Right.
right? And that's the zoomed out view that lets us see how one plane turns into another plane. And the TOK gives us those four planes. Now, how is the PTB related to that? How is it an extension of it?
Beautiful.
How does it offer more details, right? About because the
Right.
TOK is very zoomed out.
L-
The PTB is more like nitty gritty about what's really going on in there. So, how
Totally.
is that the extension?
Right. So you just look at the big picture gestalt of the TOK and you say, hey, here's a general map of behavioral complexification. And it says that there's these clearly what jumps out at you, these different four dimensions. Okay. And that's an unbelievably crucial insight out of an original energy information dimension. There are these matter, object, life, mind over time. That's the big. But ultimately, then there are a lot of questions that ask, what does it really say about emergence? Okay, and what do we actually model this? And what the PTB says is actually, if we really pay attention and then zoom in, we can delineate, which is not done nearly enough if it's done at all, that there are actually three categories of emergence that are implicit in the tree of knowledge that make that pop with the PTB. That's one assertion. And the other assertion is that UTOK is helping us understand the relationship between science and behavior, and the PTB makes that much richer also. So let me talk about the first, which is the argument is that when we think about emergence, there are actually three different kinds of emergence that we should differentiate at a descriptive level. One is the aggregate emergent. And at the top of the PTB, you see object field relation. Okay. And so that's just basic. Yeah. So what it says is there'll be patterns in nature that would form, like, for example, a stream, okay, is an aggregate, let's say water, obviously stream would have a lot in it, but we'll just call it water, that has fluidity in it, that's running. And then it creates it carves a thing it carves a canyon, Grand Canyon, okay? So that has aggregate, lots of molecules come together, create fluidity. Those are generalized properties that have particular kinds of causes. That's what a lot of people think of when they think of emergence, and that's the most general and weakest form of emergence. But it's different than all the stuff coming together and properties that aggregate out of that are different than integrated differentiated properties. An integrated differentiated property is when a property, a part, jumps in together with another part to create a metastable whole. Okay, so that here we can think about an electron and a proton jumping together to form a metastable hydrogen atom.
Mm-hmm.
Okay, so they become, notice in a stream, you just have aggregates. You don't have integrated differentiated parts. You just have aggregates with properties. And then with a jump from a particle to an atom, you then have metastable wholes that are then, and indeed the periodic table of the elements is a map of the structure of the atomic metastable wholes. So you go from hydrogen, helium, hydrogen, and then it says actually there's these orbitals that give rise to the patterning of the particular kinds of atomic structures. And that's floor two on the PTB, which is the structure of atomic potential. And so then you get into a second element. And the second element is that there's a patterning of complexification, meaning there is this integrated part that then we can actually follow a whole trail of from the beginning to where we are. Not that where we are was destined, but where we are looking back, now trailed back to the beginning. Tyler Vogt calls this combigenesis. Okay. And this is different. It's a part whole integrated group, integrated structure that is the trail. That's different than complexity in general. It's complexification. It calls combigenesis. And so that's
bring back the TOK, that's the complexification, the ongoing dynamic of complexification going on within the planes of existence,
exactly,
right? As
exactly.
they turn into another.
Right. So what happens to a molecule? What happens to an atom goes to a molecule. How do macromolecules get together like lipids and carbohydrates ultimately form things like genes and then cells? And then how do cells form groups, multicellular organisms, groups of multicellular organisms, ecologies. Neuron nets get together to form brains and animals. Well, I mean, animals are more than, of course, that, but then that becomes a higher, then you get animals communicating with each other to get animal groups. Then you get propositions as a particular intersubjective kind of binding, giving rise to persons that bind in groups. Each one of those is part of the complexification pattern. So there's an emergent complexification line versus an emergent aggregate line. Okay. And the tree of the PTB maps these with specificity. We'll come back to how it does that in a sec. But it also is the cousin or extension of the tree of knowledge. So it also says, actually, we're tracking complexification. But not only do we track complexification across part-whole integration, there are these jumps in dimensions. This is the key insight of that the PTB picks up. What the PTB says is actually there are metastable primary units for each one of the dimensions. Okay, so that we can
again here. So
yeah, so that's the if at the bottom layer it says an atom. So the matter object dimension of complexity, science has helped us see that it's actually organized by atoms. And of course, atoms can get together in groups like molecules forming water. But the core unit at the matter object is an atom. The core unit at the life level is a cell. And then the core unit at the mind level it's listed as mind one there, but it's the minded animal behaving in context. And then mind three is the justifying person behaving in context. So it basically says there's objects, the overall category is objects, organisms, animals, and people. And then we get down that there's specific primary units of organization.
All right, there was a big cut there. That's because we had some technical issues. But we're back, and we just left off at identifying the primary insight of the PTB, right, which is the fact that each plane of existence will have a primary whole or a primary entity in it. So for matter, we're going to have the atom, the cell for life, mind one, which is the animal as a whole for mind, and then the person, the justifying person for the culture plane of existence.
Exactly. And then by seeing that, so a stable entity that then has made up of parts beneath it, and then forms into groups above it. That's then the bottom layer, and that's really where you get the primary insight, that there is a part-whole group within, at a primary level, within each dimension of complexification, which is not present, or it's not clearly delineated in the original tree of knowledge, but the PTB makes that clear. And by elucidating a primary unit, a primary entity, then there's parts that make up that entity, and then there are entities that form into groups. And it is that complexification, notice that's integration and differentiation of parts, from parts to whole to groups, that form the core structure of complexification in each dimension.
And on the tree of knowledge system, then you have what we call the join points, right, which are the ontological jumps between one plane and the other. And we characterize them as feedback loops that are going on. And I think the PTB describes that even further, right? And how can we relate then the idea of the join points that form a different plane with the insight here?
Good. So what you're seeing here is complexification, behavioral complexification, and it's exploring different design spaces. And then if you get the right environment, then you get a propagation of design space potential that then leads to a variation, selection, retention, feedback loop. And so what the argument is like on planet Earth, 4 billion years ago, there was an opportunity for propagation of chemicals, assuming that this is where life really gets started as opposed to the seed hypothesis. But anyway, we'll say that that gives rise to primordial soup, as it were, warm pond kind of ideas, or other kinds of environments that give rise to chemicals coming together, having an opportunity to create these large-scale molecular groups that then variation, selection, and retention. That's then the jump between the matter dimension at the gray and then into the green. That then gives rise to life, and then they get organized around cells. And then if you fast forward, then you have multicellular animals or multicellular organisms. And then one set of those are like jellyfish, and they have sensory motor neurons that are actually quite differentiated at first. They get consolidated into things that are akin to planaria worms. Then you get a bilateral plan, and they're moving around, say, 700 million years ago. The Cambrian explosion is when animals started eating animals, where you get prey predation, and then you get these complex active animal bodies now really exploring 3D behavioral space, and we now know that's minded behavior, and that's the complexity building feedback loop. So, and then ultimately propositions are doing that at the person level. So this binds together the structural complexification, the aggregates with the feedback loops. And so that's you get the three models of emergence: aggregates, complexification within the dimension, and then a complexity building feedback loop, which are then bound together, at least at life, mind, and culture, by novel information processing communication networks.
Lovely. So you have this movement right here on the PTB, the horizontal line of the different parts and wholes and groups, and the expansion of those groups, like exploring the space, right? You have the little arrows there,
The
perfect.
little arrows jumping
And then
up.
the jump on the y-axis through the different planes.
Totally.
So lovely. I think that's very helpful for understanding emergence. And I'll link in the description your paper with Tyler Vogt, because I think that's also a good
Totally.
complement to this.
Totally. His quirks to culture clarifies general complexity versus complexification, what he calls combogenesis. Then we synced up, and we also then saw he at the end of his book is like, oh, there's these different realms too, which are these different dimensions. And like many, not no offense, but many, he identified the matter, life, and culture domains, but he missed mind. He now sees that. We bind it together and said, oh, yes, these realms are really different dimensions, and now we can have a realm, or by combogenesis, to use his language, or dimensions by complexification, to use mine, and they're the same thing. And yeah, we get a whole picture. And so that really, and now if we go back to mindedness, we really are saying, oh, we can see mindedness in the world as this third dimension. Now we can see it as part of behavior through a lens. And also what's happening with the PTB is this bridge between behavior and science, at least at a higher level of analysis. That we then, at the tree of knowledge, we see on the right-hand side of the classic tree of knowledge, we see the table of science, material science, into biological science, into psychological science. But actually, what it really is, the specification of the way science has evolved in terms of its own integrated differentiation process. Like, how is science complexified? The argument is that if science is mapping behavior, and if this is a good map for behavior, there should be a tight correspondence between the domains of science and the ways in which these patterns of behavior evolve: aggregate patterns and complexified patterns. Okay. And I would argue you totally see that. Like, for example, in the material sciences, you go all the way back to physics, right? And then that in your, like, that's the ground. And physics then starts, the ground of it is cosmology, which is the largest aggregate of the universe as a whole, versus particle physics, which is then the most particular. Particle physics stacks into chemistry, basically at the periodic table of the elements. That's the second floor. And then into chemistry at the level of molecular change and structure. That's what chemistry is really, the floor 2 to floor 3. And then aggregates are things like geology, the solar system, galaxies, and the universe at large. Those are aggregate systems in astronomy, or earth science, and those are all part of the material sciences. So we can actually see the differentiation in science tracking these different emergent elements, and then that goes up. Yeah, go ahead.
Yeah, and up here the PTB shows, right, the big domains of science,
Yep.
and if you do the alignment with the different levels, the different steps of the PTB, you will have that alignment. And I think especially important is the alignment with psychology, right? Because UTOK adds the mind dimension and that's mindedness, and you can track both what we call basic psychology in UTOK, right, which is animal, non-human animal psychology, and then human psychology at the culture person plane.
Totally. I'm glad you brought that up, because there's another assertion that's being made about the science relative to behavioral complexification, and that is we have relative consilience for the physical and the biological sciences. And indeed we do. I would argue that you can take the first 7 floors of the PTB and say, oh, that's natural science. That goes from particles into atoms and molecules. And then you jump into things like genetics, biochemistry, molecular biology, into cytology, study of cells, into organisms, botany, mycology for fungi. Then you go into neuroscience, okay? And then in biology, you get to what's called ethology. Ethology is the science of animal behavior. That should be okay, where you get the same place that should be minded animal. Okay, but ethology is the science of animal behavior, and then you get behaviorism, okay, the science of behavior, which is whatever that is, which is actually animal behavior, right? And then you get cognitive psychology, which says, oh, there are mental processes that are somehow separate and magical, potentially, or separate causal processes from biological processes. Well, how does that work? UTOK will tell you how that works. But notice that ethology is a biological discipline. Right. Behavioral psychology, cognitive psychology are psychological difference, and they actually intersect right there. We have the same point in the complexification being completely competed against. Behavioral psychology, ethology, and cognitive psychology all are about that domain.
Right, and you get also things like behavioral neuroscience and cognitive science, right?
All of the right, cognitive neuroscience, they would all then be pulling up either brain or behavior binding to mind poorly defined. But if you do mindedness as the overall class, and then the behavior of a complex adaptive system of a minded animal, and you say that 4E cognitive science really is science of mindedness, an embodied, embedded, and acting animal, and then inside of that is what cognitive psychology is pointing to with its quote unquote mental processes. That's the neuroinformation processing structure. Okay, mind 1A, and the behaviors are pointing to mind 1B. Those are the overt behaviors of animals that are responding, demonstrating functional awareness and responsivity. So we can then see that, oh, they don't have the puzzle piece made. The descriptive metaphysics is missing. And now we can say, oh, there's minded animals. And of course, hidden in all of this is going to be a way of delineating our next episode when we get into, well, wait a minute, what's really complicated here is this thing called subjectivity.
Right. I was about to ask that, right? Because we see mind 1, we see mind 3 in the PTB, but we don't see mind 2. Mind 2 is subjective conscious experience in the language of UTOK. So, where is mind 2 in the context of the periodic table of behaviors? Why is it not there?
That's great. That's a wonderful question. And part of the answer is epistemologically. So the first thing we'll say is epistemologically, the periodic table of behavior is a lens of behavior of the exterior behavioral third person epistemological position.
Men's knowledge.
Right? Men's knowledge, which I argue is then grounded in that kind of epistemology. Okay. But by virtue of being grounded in that epistemology, then what is justified is observable knowledge tied to, okay, the structure of understanding and the methods that observe it. Well, what is mind 2? By definition, that's an interior epistemology. So as the evolution of an interior subjective knower emerges in the world, if we say that, at least currently, and we can get into this, a very complicated question, but simplistically, it's obvious that it's ontologically the case that the third person can observe the first person vector of understanding. This is where you get so you have the epistemological gap. That's what we call it. And it's not part of the world. And exactly what is that is the hard problem of consciousness. There's an epistemological gap, and then ontologically specifying how that emerges is the hard problem. Okay. But the PTB simply says, put on your science glasses, and this is what you'll see in the world. Mm-hmm. And then you can see very clearly why mind 2 is a tough, different, weird concept. Okay. But if we take at least a standard view, now we can get into what all these different definitions of consciousness, where it might come from, all this other stuff. Let's just take a standard view and say it happens with brains and animals. Mm-hmm. And then we can say it emerges, and that's really what, at least mind 2, whatever you define consciousness in general, subjective experience in animals is emerging. Mm-hmm. It's not in the liver, right? And it's not in the bones. It seems to be pretty clear that it's in the brain stem into quote unquote limbic system, midbrain, and cortical structures. And we can dialogue into exactly how all that happens. But that's the location of it based on our modern understanding, at least, a conservative modern understanding. So that's where it is. The reason it can't be seen is because the PTB is a behavioral epistemology anchored to natural science epistemology, which then makes perfect sense in relationship to that.
Mm-hmm. Lovely. And we'll get into those epistemological differences next time on the map of mind, right? The map of mind does that beautifully, I think, in making those distinct in the context of mental processes. So we'll get to that. I'm looking forward. And especially, the difference between consciousness and mind in UTOK, that's very helpful in understanding all of this. So we'll touch on that.
Yeah, we'll dialogue a little bit about that next time. But what we've done now is we have said, hey, we need a descriptive metaphysics. Psychology fails. We need actually science, behavior, mindedness. We've shown that. We did mindedness. And then we do in behavior, binding it to science. Now, next time we map a mind to get clear about the subjective relative to this objective vector, and then show the various domains of human mindedness, mind one, mind two, and mind three. We're going to tie that to consciousness, and then we'll have a cool descriptive metaphysics of the whole picture.
Lovely. All right. It's
All
always
right.
fun to do this with you.
Well, thank you so much for these good questions.